Hello everyone, my name is Thomas Wimmer. I'm working as a software architect at netcetera here in Linz, and in the next 10 minutes I will introduce you to an architectural pattern called Hexagonal Architecture. But before jumping directly into the principles behind hexagonal architecture, let's revisit a common architectural pattern probably every software developer knows about, namely the layered or anti-architecture. The main idea behind this architectural pattern is that you divide your software system into a number of layers, whereby each of these layers represents a certain technical aspect. As an example, when you as a developer are working on some UI components, you shouldn't be concerned about where the data you're currently displaying is coming from or how it is assembled. What we see in practice is that for a complex system, those three layers are usually not sufficient. So what you do is that you divide your software system into a bunch of more layers. Thereby, each of the upper layers delegates some part of its work to the lower layers. Thereby, every layer follows the rule that it can only talk to the direct lower layer. So this was a quick refresher of layered architecture. Let's look on hexagonal or ports and adapters architecture. The main idea behind this architectural pattern is that you divide your software system into an inside and outside world. Thereby, the application core in the inside interacts with some outside components over so-called ports. Thereby, the actual interaction with the outside components happens over so-called adapters. Quite easy so far, right? So let's look at it a little bit closer by following the control flow of a usual user interaction. If some user of our system wants our system to do something, he calls the UI adapter. So therefore the adapters which drive our application, telling our application to do something are called driving or primary adapters. In order that the UI adapter can do something with the application core offers some input ports. These input ports accept some commands and queries to be executed towards our system. Now that the command is executed towards our system, the application core is doing its business logic, some business rule validation, maybe even some complex calculation. And in order to fulfill its business, he might need to interact with some external system. So therefore he calls so-called output ports towards the external system, and this interaction on the output ports are then interacting with the adapters which do the actual integration towards the external system, and these adapters are then called driven or secondary adapters. So now that we refreshed or learned the principles behind layered and hexagonal architecture, you might be wondering, what is the essential difference between them, right? In order to figure that out, we will compare the visual representation of these two architectural styles. But the visual representation which are usually used to describe those architectural patterns, namely this one here, do not allow a fair comparison. So let's deflate the representation of the hexagonal architecture to allow a better visual comparison. If we closely look on this difference here, we will see that beside the naming of things and the ports, we encounter that some arrows are pointing in a different direction. We see that the dependencies between the business logic and the data layer of the layered architecture are pointing in the opposite direction than the application core and the data adapters of the hexagonal architecture. Or phrasing it differently, in the hexagonal architecture, all dependencies of the outer layers pointing towards the application core. Let's analyze what are the implications of this difference by recalling some solid software design principles. You probably remember the single responsibility principle. It states that a class should have only one reason to change. But applied to a higher software architectural level, we could also say a component should have only one reason to change. Or phrasing it differently, when you change one component of your system, you don't want that another component of your system is affected by this change. So let's look at an example. When you change the data layer in a layered architecture, this change might be reflected in the business logic because of the dependency, right? And then if you change the business logic, this change might be reflected in the UI because of changes in the business logic and the dependency. If you think about it for a second, you will notice that in a layered architecture, the upper layers have always more reasons to change than the lower layers. So the idea behind hexagonal architecture is that changes in the adapter do not affect the core and vice versa. Robert C. Martin, who introduced those principles, describes this to a new principle in his recent book called Clean Architecture. He states that you should gather together those things that change at the same times and for the same reasons, and that you should separate those things that change at different times or for different reasons. He calls this the common closure principle, and in fact this is the single responsibility principle applied on a higher software architecture level. Another important principle which is applied by hexagonal architecture is the dependency inversion principle. It consists of two rules. The first rule states that high-level modules should not depend on low-level modules, but both should depend on abstractions. So what are the high-level modules here? The high-level modules, for example, in our layered architecture is the business logic. And as we see, the business logic depends on some low-level detail, namely the data layer. Therefore, this business rule is already violated, right? And it also states, so the first rule also states that both should depend on abstractions. Well, in the layered architecture, we don't see any abstractions. But in a hexagonal architecture, we see that we introduce some ports, which are our stable abstractions. The second rule states that abstractions should not depend on details, but details should depend on abstractions. So what are the abstractions here? Again, these are our ports, right? So the ports should not depend on details, so the ports should not depend on the adapter or even the application core. This is the case right here, right? And it also states that details should not depend on abstractions, so that the details should depend on abstractions, so the adapters in this case should depend on the ports as well as the application core. So the key here overall is that we introduce stable abstractions, or in a statically typed programming language we would say interfaces to that, so that high-level concerns are not affected by changes of low-level concerns. Also, Robert C. Martin maps this principle to a higher level. He states that components which are difficult to change should not depend on volatile components. Otherwise, the volatile components will also be difficult to change. So, what are the volatile components in a software system? The volatile components are those components we want to change. So our business logic, our infrastructure code, these are things we want to change. Our software should be easy to change, right? What are the stable components in our system? The stable components of our system are the contracts we introduce between our system components. So our interfaces, or maybe even some system dependency, like the string class in every programming language, for example. We can express this stable dependency principle also in hexagonal architecture terms and could say ports should change infrequently and should not have dependencies. Let's recap what we learned in the last few minutes. We learned that the real difference between layered and hexagonal architecture is that the direction of the dependencies are different. And we also learned that the hexagonal architecture fulfills the single responsibility principle by fulfilling the dependency inversion principle. And in fact, this is all possible only by introducing stable interfaces between our software components. If you are further interested in learning about hexagonal style architecture patterns and maybe even want to implement them in some of your recent projects, check out the books by Robert C. Martin and Tom Homburgs about clean architecture, or check out one of the blog articles which I stated here. All of this has been used as some references for this talk. And of course, I always like to have an exchange about software design topics, so don't hesitate to contact me either by mail or on Twitter so that we can have a conversation about these topics. And who knows, maybe we can have these conversations even soon as some colleagues in one of our offices in Linz, Hagenberg or Vienna. Thanks for watching, see you around.